morning, Trig fans. How we doing on this fine Wednesday morning? It's a beautiful sunny morning out there. It's going to get warmer. Might get some rain, but I'll take warm rain. It's going to be a nice day out there today. Go out there and enjoy it. Maybe mow your yard out there before it starts raining. Hope everything's going well for you and your family at home. We are nearing the end. It's getting close. This is my favorite time of the year. It is. This is just a great time of the year. It's a great time of the school year. Even though we're doing in this direction or doing this type of learning, it's okay. You guys have done a great job. I'm very proud of you guys of how you've reacted to the situation. But you know, closing out the school year is always a fun time of the year also. We're going to go over a couple problems from your homework from yesterday. I will put a review sheet up, and tomorrow we will do an evaluation just like we've done the last couple weeks. So let's take a look at, I think it's problem number 4 at the bottom right hand corner of the homework problems that you had. I wanted to calculate a minus x. Okay, and I have a going to the left, I have x going up. These should be vectors. And the magnitude, these are magnitudes. That's fine. Of the vectors are 7 and 9. And I want to calculate a minus x. Well, the first thing I want to be able to draw is draw a minus x. Okay, so I need to be able to draw the vector, or the problem. There's my a. Not cooperating. Here's my a going in this direction. But then I want to subtract off x. Now, if you remember what we have to do when we subtract off x, if I was adding x, I would put tail to tip, and that would be the addition I would draw on my resultant vector. But I'm not adding here, I am subtracting. So what I have to do here is go in the opposite direction. Positive x is going that way, that means negative x is going down that way. So I could just take it and turn and go in this direction. And this would give me negative x. So here's my a and here's my negative x. Okay? Put a up here. And then I want to find the resultant vector. So I need to calculate this right here. What is VR, the magnitude of VR? That is the a minus x. Well, what we talked about before is how do I calculate this angle here? A is a measure of 9, x is a measure of 7. Even though it's a negative x, the measure of that is still the value of 7. It's the magnitude. The question is, what is this angle here? Well, let's take a look at what we're doing here. Okay, we are just sliding this over. I'm going to clone this. Might be able to see it better. I'm just sliding this over to here, but then I'm turning and going in this direction, the opposite direction. So what is my relationship between this angle and this angle? Well, those are called, once again, alternate interior angles. These lines should be parallel. This is my transversal. These would be alternate interior angles. So the angle that is formed here is 50 degrees. Now I have my law of cosines I could set up. So we have VR squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 cosine of 50 degrees. So if I do some calculations, 7 squared, oopsie, I'll go to this calculator. 7 squared plus 9 squared minus 2 times 7 times 9 cosine of 50 degrees. I get 49.0087. So I need to square root. Oopsie. That didn't go good. Oh, that didn't go good. Let me go back. So I'm going to square root my answer, and I get 7.00, which is, and a little bit more change. Okay, the question that is also asked is, what is this measure of this angle? What is the measure of this angle that's formed with angle A? So what I want to be able to do here is, I'm not sure what my triangle looks like here, so I'm going to use my law of cosines, where I have 7 squared equals 7 squared plus 9 squared minus 2 times 7 times 9 cosine of alpha. I guess I could have probably used law of sines here too, because 9 is my biggest side here. So this has to be the biggest angle. So that would be, if there's going to be an obtuse angle, that would be it there. So I could use also sine of 750 over 7 equals sine of alpha over 7. But if I look at this, what does alpha have to be? I sort of created a nice isosceles triangle here. Both of these should give me an alpha value of 7.0. I'm sorry, 50. But I could use either one, law of sines or law of cosines. When you're across from the biggest side here, you need to watch, because if you're crossing the biggest side, this could be obtuse. So that's when you should use your law of cosines to find your alpha value. But if you're not crossing the biggest side, then you could use your law of sines to find your alpha value. The second problem I'm going to do is, I think the second problem on the back with the bearing. Plane travels 150 miles in a bearing of 310 degrees, then turns onto a bearing of 270 degrees and travels 250 miles. Find the distance and direction of the resultant vector. Well, what we need to be able to do is get a picture of what is going on here. Plane's going to travel 300 on a bearing, 150 miles on a bearing of 310 degrees. So what we are going to do here is we're going to start with the north here, and we're going to rotate this. Whoopsie. Let's try this one. We're going to rotate this 90, 180, 270, and take it up to here. That would be a bearing of 310 degrees. And they've traveled 150 miles on that bearing. Okay, what we talked about yesterday when doing bearing problems, what I suggest you do is where you end your first vector, you draw a little axis there. So you have a reference point in regards to your second bearing. Well, my second bearing, going up here, that's my north. I travel on a bearing of 270 degrees, 250 miles. So we rotate 90, 180, 270, and we're traveling 270 miles, or I'm sorry, 250 miles. Oopsie. What we want to be able to find is the distance and direction of the resultant vector. So we want to be able to find this, the resultant vector. So if we take a look, I know two sides. I need to be able to find this included angle. And the included angle, once again, is sort of like the puzzle that you have to try to solve with these problems. So I know I have a right angle there. That gives me 90 degrees already. Okay, so I'm good with that. What I need to be able to calculate is I need to be able to calculate the measure of this angle. Well, I used the first bearing to get this angle. I'm going to have to use this bearing to find this measure of this angle. Well, if the question I'm going to ask you is if I rotate 310 degrees all the way to this orange reddish vector, how many more degrees do we have up here? If this rotation is 310 degrees, how many degrees more do we have to go a full way around? Well, it's 360 degrees, so we have, yes, 50 degrees. If this is 50 degrees, now I can use my parallel line, the vertical lines are parallel, and here's my transversal here. I can then find the measure of this angle to be also 50 degrees. So this entire angle inside is going to be 140 degrees. Now I can use my law of cosines. VR squared is equal to 250 squared plus 150 squared minus 2 times 250 times 150 cosine of 140 degrees. So going to our calculator, we have 250 squared plus 150 squared minus 2 times 250 times 150 cosine of 140. A big number. We could square root, second square root, my answer, and we get 684. That doesn't make sense. I put in a big number up there. 250 squared plus 150 squared minus 2 times 250 times 150 cosine of 140. Let's try that one. And then we could square root that answer, 377.43. 377 miles. Well, I go 250 and I go 250 and 150, that's a total of 400, but if I go on an angle, it's only 377 miles. We have to find the bearing. To find the bearing, we have to look at the angle that's at the original origin. So we're going to call this alpha, and we have to calculate this angle here. Well, this is going to be an obtuse angle already, so I don't have to worry about obtuseness. I could take the sine of alpha over 250 is equal to sine of 140 over the 377.43 that we just calculated. And once again, here's a little trick for you. We have 250 times the sine of 140. So we have 250 sine of 140, and I'm going to divide by, here's my answer still, my answer. And we'll have to take the inverse sine of that to find our angle. So I could just pull my answer down again. So we get 25.2 degrees. The question is, what is the bearing of my resultant vector? Which means I'm looking for just this rotation here. Well, when I rotated my first vector here, I rotated from here all the way to my red vector there. That was 310 degrees. I want to stop short of that to get to my resultant vector. Well, how many degrees short am I going to be? Well, that's my alpha value that I just calculated here. So we could take the 310 and subtract off the 25.2 degrees. Let's see, I'll do it old school. We have 8, 9, 0, 4, and 284.8 degrees. And that would be our bearing. Hopefully these problems help you out a little bit, walking through these problems again. Once again, I will post a review sheet for you. It's going to be drawing vectors. It will be problems that are like this here, and then some problems that are like this here. That will be the evaluation I will post tomorrow, and that will be due on Friday once again. And next week we have one last topic to cover, and that's called polar coordinates, and that's a relatively easy topic to be able to cover. This is probably a little bit more difficult just because it's a little bit more additional work. If you have any questions, feel free to ask, feel free to comment to me. I'll try to get to them. I'm going to mow the yard today because it's going to rain the next 2 or 4 days, but I'll try to get to them sometime soon today. Other than that, I have nothing else for you. Wish you were here in school. I wish you were sitting at my desk right now, but oh well. It's just our new norm. It's okay. We'll be fine. Other than that, I have nothing else for you. Adios. Say have a good day.